welcome to the Rich Report, a podcast with news and information on cloud computing. Today, my guest is Kyle Forster. He's a VP and co-founder at Big Switch Networks. So, Kyle, welcome to the show today.
Oh, thanks so much for having me, Rich. I appreciate it.
Oh, it's my pleasure. I have some questions about Big Switch, but I thought we'd just start with your overview slides here. So I brought those up now. Why don't we start with that?
Perfect. I figured that I would just spend a few minutes talking about the company. A little bit, we just sort of announced our open SDN architecture. I'd talk a little bit about why I think that's important. And then we'll go into, I think, just with the slides a little bit, why we think this is generally a huge change for the networking industry. So on the first slide here, with people at Big Switch, I like to introduce this because I think it's just important to understand the DNA of the team that's coming that's sort of generating some of these perspectives. If you look at it, we're an early stage Silicon Valley startup here. I think of our company really as an engineering team with wheels attached. We're 32 people right now. We're about half PhDs, about 80% of some kind of graduate degree in networking. And we really come from three primary areas. My co-founder, Guido Appenzeller, was actually the professor at Stanford who led the engineering arm of the team that developed the OpenFlow 1.0 specification. They developed the reference switch, the reference controller, and of a ton of interest to us, all of the research around using SDN for network virtualization. So that's right now, they're about a third of our team. About a third of our team comes from VMware. Our VP of engineering, Howie Shu, was actually the co-inventor of the vSwitch. He led about a 120-person team or so back at VMware that basically their whole networking R&D team. So he came over as our VP of engineering, and then from general networking industry, the rest of our crew comes from Cisco, Arista, Juniper, and HP. So I think, we just did an announcement earlier this week about our open SDN architecture, and I just wanted to note here, there are three elements that I think are very important as part of the overall open SDN push. I think what you'll find is that relative to traditional networking, there are three areas here that are interesting and new. The first is the use of multi-vendor standards. Networking has this for a while, but I think OpenFlow itself represents a fundamentally new and exciting standard for the networking industry. And you've seen 30 different members join the Open Networking Foundation that really supports this standard and a whole series of products coming out around it. So I think OpenFlow is really important. The second, and I think for a lot of folks who come from the compute side, it's amazing that we have to call this out, but in the networking industry, the concept of open APIs so that you can integrate code with all kinds of other products out there, for the networking industry, that's a new concept, and not everybody adheres to it. I know it sounds crazy for folks coming from a software background, but it's just been the history of the industry for 30 years. So we really try to call this out, that a big part of this SDN movement is all about offering open APIs, because we should be able to compose different pieces of software. We just think that's a really, really important fundamental shift for the industry that we've got to go to really modernize networking. And third, just the inclusion of open source into networking. We think that there's a really interesting marriage here, and I'll talk more about those in a few. On the next slide, if you look at traditional networking is kind of a box by box. A packet enters a switch, the switch runs some magic, checks the user configuration, and decides what to do with the packet. With software-defined networking, the theory of operation is quite a bit different. The whole idea is, let's just walk through this for a second, that a packet goes from generally a virtual machine, but could also be a physical machine, and enters its first OpenFlow switch. Now, OpenFlow is getting a lot of traction, both for top-of-rack switches and for an interesting part of the networking ecosystem, the hypervisor vSwitch. It's a part of the networking ecosystem that some people view as networking, some people view as compute. But the gist is the packet enters. The packet's actually forward to what's called the OpenFlow Controller. Right? That's actually a piece of software running on a series of servers in a data center. The controller does a database lookup on the source and destination of that packet, and can pull up all kinds of interesting data from a very clean, enterprise-grade database. So we're no longer talking about, firmware written onto a box. We're talking about commercial-grade enterprise software. After that lookup, the controller sends down what are called flow table entries to all of the switches on the path of that packet. That means that any packet going through that path, right, from that source to that destination, matching those parameters, they're going to go at line rate. So if you look at it, the net result is that you wind up with this really clean mix of easily malleable software, right, instead of on-box firmware. But at the same time, you get the performance of traditional networking gear. On the next slide, just a quick note. While if you really unpack the software, the firmware that's sitting on an Ethernet switch or router today, you'd find something that generally looks like this a bit in some of the software structures. We view that the key part of this database lookup, is an extremely important part to keep open. We think that by keeping this open, people can reach in and build up an awful lot of new networking applications and simply extend the capabilities of the network in interesting and cool ways. On the next slide, if you look at a traditional Ethernet switch, in many ways, I think the mental model here is that the data plane is represented by line cards in the switch, and the control plane is represented by supervisor cards. Right, the data plane is generally what's sort of doing the line rate forwarding of the packets, and the control plane is making the decisions about, okay, a packet just came in from this source. Which of these many ports do I forward it out on? If you look on the next slide, what sort of the SDN perspective is that you effectively have this cluster of server software that represents the control plane, and your entire network works together as one data plane. Think of it like every switch in the network effectively becomes a line card in, well, given our company name, what we like to think of as one big switch. On the next slide, I think you'll see just a note about what these architectures look like in practice. In the production networks that we're part of, it's a very clean 3-tier architecture that keeps showing up as people build out their high-performance networks. There's a data plane here, which is primarily the physical switches and the V-switches that we've been talking about. There's a controller tier, which represents really just a series of shared libraries for the exciting part where the application, where a lot of the control plane actually lies, which is in what we call these network control applications. I mentioned here virtual network overlays. The concept of a virtual network overlay is probably the number one. We think that's going to be the killer app. We're certainly working on it. There are a number of other companies out there in the space that are working on it. Most of it based on the concept of FlowVisor, originally developed back at Stanford. So if you kind of look at when you build these things out at scale, generally this 3-tier architecture is where it happens. On the next slide, I have a quote. This is from a blog. It's almost 2 years ago now, but we show this around a lot. This was from James Hamilton, the chief architect at Amazon's data center.
Oh yeah, I know this guy.
Okay. He's got this great blog where he just, starts listing some of the projects that they're working on, or alludes to some of the projects they're working on. And the entire blog is a rant about how the network is in my way. I think that kicked off this whole ethos of, if we flip onto the next, if you have a network, you should be able to add control applications to your network. You shouldn't have to wait for vendors with these boxes that are just welded shut. You should be able to add your own apps here. You want to control your network in a certain way, you should feel free to do it. I think a second part of what we believe is, this shouldn't require intensely specialized knowledge. A Dijkstra shortest path algorithm is something that is very, very well understood. And since that sits at the core of so many networking problems, if you can write a shortest path, then it shouldn't be impossible to get something working without buying 100% new equipment. The last is that we believe very strongly that there should be an open source community out there to go for help when a project gets too big and need to pull in more people, pull in just different types of expertise, pull in different areas of networking knowledge. So we think that this open SDN is really a response to in our view, to what James was looking for. On the next, I think if you look at their, an increasing number of folks out there agree. We're actually, every time I show this slide, it gets a little bit old because the numbers, we've now actually passed 2,000 downloads for Floodlight, one of the pieces of the open source controller that's out there. Here are a couple of the projects. I'm showing the chart that what I'm showing is visitors actually showing up at the openflowhub.org open source exchange website. Floodlight is an open source controller that we actually launched There's Flow Scale, Load Balancer, Indigo, which is actually open source firmware for the Broadcom reference design switches. RouteFlow, which is using an open SDN approach for routing. So an increasing number of both projects popping up. There are probably another 12 or 14 major open source projects that I haven't shown on this slide. And you can tell really starting in January of this year, the interest around OpenSDN is starting to dramatically pick up. So that's the last slide that I have. Rich would love to just chat a bit if you have some questions about it. It's an area that obviously I'm very passionate about.
Sure, Kyle. Well, first question that comes to mind is, I hadn't heard of OpenSDN, of course, but can you contrast it with OpenFlow, which has been around for a while?
Sure. So OpenFlow is the core protocol that, in our mind, makes SDN and OpenSDN possible. OpenFlow is the protocol that runs in between the controller tier and the data plane tier. When we look at OpenFlow itself, version 1.0 of the OpenFlow protocol it's a 27-page long protocol spec. That's it. Most networking protocol specs are deep in the hundreds and sometimes even thousands of pages. This thing was 27 pages long. So it's a very clean and beautiful minimalistic spec. But that describes the interface in between the control plane and the data plane. If you start to compose the applications, the controller, and the data plane, just that sort of the bigger picture piece, that's generally what we label as SDN or SDN architectures.
And, for a startup like you guys, before you get any money, you have to characterize the market opportunity, right? So what does that look like for something like this?
The way that we actually did the market sizing. We looked at, we did a big cut across enterprise data centers, and including some public cloud data centers and even some on campus. And we said, how many switches out there do we think have incredibly complex configurations? Because what we realized is that's where the pain is most felt, where people are trying to build networking logic, but they're building it on box by box configs. And these configs, back when I was at Cisco, it was normal to see boxes with 4, 5, 6,000 lines of pretty hairy and convoluted config. We figured there was somewhere around $5 billion a year spent on boxes that became, in our mind, complex config boxes.
So you have the opportunity, and you lay the groundwork with the OpenSDN software. What's the next step for Big Switch Networks as a company?
So for us, we're very actively growing the ecosystem around. Floodlight is actually the core of our commercial controller, which we open sourced. We're actively growing a community. I don't know how many folks have reached out to us. We're running 1 or 2 a week at this point of both big companies and startups who are reaching out to us building their own products on top of Floodlight. What we're doing is Floodlight for us is the core. Our commercial product basically adds a whole series of modules around Floodlight. But our invitation is that anybody can write an application on top of Floodlight. Our commercial product helps sort of build out a bunch of common libraries just because we've built 5 or 6 applications now and we can kind of see the common stuff. And then we're in beta with what we think is going to be the killer app on top of these controllers, a network virtualization application. We're in beta now, and it's going to be an interesting next couple quarters.
So kind of a wrap-up question here, Kyle. You guys are new. You got some new stuff that looks very interesting. How do people engage?
The first thing that I always point people to is the openflowhub.org open source website. If what you really want is to find something that you can get up and running, very quickly and easily on a lab bench. We actually distribute a virtual machine there that has both a controller, a handful set of apps, and also has a network simulator that you can simulate, a decent laptop, probably up to 40, 50 switches, and maybe 150 hosts. So you can get at least a little bit of time in the saddle with the basic architecture on a pure open source basis. If it's more of a commercial thing and it's less sort of tinkering out in the lab, then certainly bigswitch.com, our website, is a very, very clean way to get in touch. But I'd urge people to look at either of those places.
Well, terrific. Well, Kyle Forster, I want to thank you once again for coming on the show today.
Hey, thanks so much for having me, Rich. I appreciate this.
You bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on cloud computing.